while hunting around on eBay, as usual, I found these little 2-in-1 testers being sold, and I got a couple to take a look at because it's very clear that, there are slight differences between them. This one is rated 6 to 380 volts and this one is rated 10 to 380 volts. And the 380 volts alludes to the probability that these are a bit of a clone of a tester made by a company called Steinel. And when I was an apprentice, I had a Steinel tester. It was my first set of test lamps. And it was very simple. It was like this but black, and the 2 red LEDs that physically stuck through the black housing, which was actually a better option than this. That would actually have improved this. And if you stuck them across AC or DC up to, well, right up to 415 volts, it would give, the LEDs would light. And on low voltage, say for instance the lowest range at 6 volts, it would, if you put it across a battery, the appropriate LED for polarity that this probe was connected to would light up. So if you were on the positive terminal of this with the probe here, the positive LED would light up, and it wouldn't light super bright, but it was still very visible. And as you went up with the voltage, it increased in intensity, but then it sort of stabilised. And if you put it across 415 volts, it lit brightly and then sort of faded back down to its normal intensity. And the way it did that, it used what's called a PTC thermistor. And if I, hold on, where's my notepad? Inside the device, it was very simple. It basically had a probe, this PTC thermistor. I didn't actually know what a PTC thermistor was at that time. I think it's the first time I'd seen one. And then the LEDs, and that was fundamentally it. And the LEDs are in inverse parallel. And then to the other probe, so super simple. Now, a PTC thermistor is a resistor that changes its resistance value with temperature. And you get 2 types of thermistor. You get the PTC, whereby as it gets hotter, the resistance actually increases. And you get the NTC, negative temperature coefficient, as opposed to the positive temperature coefficient, where it's the type that's often used in these sort of thermostat type modules. And when you increase the temperature on this, its resistance actually goes down. But these ones relied on the fact that as it got hot, its resistance went up, in the sense that it started, I wish you could find those test lamps and actually check what the starting resistance of that was. But it would basically, it would limit the current to a level that wouldn't damage the LEDs even when put across 415 volts. And then as soon as the current started flowing, the resistor would heat up and it would then limit the current through the LEDs to the sort of normal level. And for that purpose, it had a very low mass, the resistor. It was actually a little tube of material with a sort of grey coating on it, and what looked like wires that were just wrapped round the end, and then sort of coated over with that material, and it just sat a bit proud of the circuit board. And it was completely hollow, so it had quite a low mass, and that must have been just how they achieved that sort of rapid reaction to protect the LEDs. Now, the reason I've got the neon screwdriver here is because these are actually, I've had a look inside them, and I'd say they're actually suitable for testing mains supplies in your house, and they're a much better option to either the neon screwdriver or these little meters. Now, these little meters do measure AC volts up to 600. They've got a 600 volts AC range. But right next to it is, next to the AC range is the amps range using the same terminals. And technically speaking, that should just be a dead short circuit on the, as near to a short circuit as possible, but still be able to measure the current. So if you did stick these leads across and then turned it around like that, then it would short circuit internally and it could blow up, because these little meters don't have proper protection. And it'd probably be potentially quite bad if you had it in the 10 amps. It might just blow clear in another setting, but the 10 amp range has a fairly chunky resistive link, and it would blow tracks off. And when these things go, particularly if you try poking it into an industrial supply, then there's a risk that it's actually going to go with quite a bang, and it's going to explode apart. The case could actually detonate with the force of electrical discharge inside. And basically the small electrical explosion, well, a large electrical explosion contained inside, and people have been seriously burnt. Their hands have been seriously burnt, their faces have been burnt, and they've been electrocuted by the fact that as it blows up, the arc is electrically conductive. The plasma These meters are not suitable. Neon screwdrivers are not suitable for mains voltage either because they've got they're more of what I'd call a technical novelty. They're neither good as a screwdriver or as a tester. Because if I get one of these detectors here and I plug this in, because it's quite handily bypasses all the safety, the idea is that if I put my finger across the end of this and then stick it into a live terminal, some current will leak to earth through me and it'll make the neon glow. But can you see it glowing? I can't see it glowing. I mean, it probably is glowing, but at a very low level. Hold on, let's get a meter. Let's measure the current through me. So let's turn this to the AC current. Move the lead over to the low AC current position. And I'll just untangle the leads here. They always get tangled up. And I shall stick this in. I shall put one of the probes on top of the screwdriver and I'll hold the other end. And it's passing about 7 microamps. And that's really low. That's not going to make the neon glow very brightly. What would happen if I stuck it to a direct earth up here? That's better. It's closer to 100 microamps, a tenth of a milliamp, which I can actually see the neon glowing now. But to get that sort of connection, you'd actually have to hold on to earth metalwork while we're using this. I'm just going to put this back from the amps position to the volts, ohms and other position because that's the best place to leave it apart. Never leave your meter in any of the amp positions because it will effectively be a short circuit, and if you stick it across like a battery or power supply or circuit, it could blow it up. So if you take a look inside these neon screwdrivers, here's the exploded version of one. You've basically got the shaft sits in here, and then you've got a plastic tube. Hold on, let's see what's all this stuff here. You've got a little plastic tube which I've completely lost now, but a little plastic tube here with the neon and a resistor in series. The idea of the neon's a bit that glows, the resistor is the protection against overcurrent flow. But this is just a 1/4 watt resistor, and they're technically speaking only rated to 250 volts DC, and even minus the 50 volts of a struck neon, then that means that if you're holding this and poke it in, a live connection, then you're already exceeding the voltage rating of that resistor, and it's not a good idea. If this is the only thing between you and potentially a high current flow, because the neon would just pass as much current, it would pass probably an amp or more happily if there was a short circuit situation. And it could pass basically. Your whole life is resting on one little 1/4 watt resistor here, and it's not a good idea. But it's a moot point anyway because you stick it in. If you're in a place that's the slightest bit illuminated, you're not going to see the neon glowing very easily. And also, it's not accurate because the current is so low to make the neon glow that it could just be leakage between adjacent cables. It could be capacitive coupling, it could be anything. You're going to get you're not going to get a reliable indication of whether power's there or not. So the neon screwdriver is just not fit for purpose. It's a novelty, it's not a very good screwdriver, it's not a very good tester, it's not very good altogether, but they still sell them. Don't use them, they're not a good idea. So we'll get back to these now, and I'll open one. I've already had one open, you probably guessed that. And inside they've got a slight difference. I'll take this to bits completely to show the construction. It's quite robust. It's got a fairly thick cable. It's got the double insulated layer. It's got the tough black outer layer of insulation plus a blue core on the inside, which means that if the cable gets chaffed, then it will actually, you'll see the other colour of the other core and it will make it obvious there's damage. That also applies to the more expensive and professional test lamps like these. So let's stick this in a holder into the power supply. Oops. So this is nice and bright. That's nice and clear. The little AC, this probably works on the same principle because although this has batteries in it, or it doesn't actually have batteries, this one, the voltage test is powered directly from the mains. And the advantage of that is it loads it down quite significantly. This one starts off about 30 milliamps, suggesting it does have that PTC thermistor in it still. I'm loath to open this one because it seems quite well sealed shut and kind of still need it. But it starts off about 30 milliamps, then it settles down to about 10 or so. Hold on, what can I test this with? Clamp meter. That'll do. Let's say I get the clamp meter around this. Let's see what sort of current it's showing. Starts off quite high and then settles down to just about 3 milliamps. And if you take it out and it sort of cools down again, it will bounce back up again. Is that visible? I think it's visible. I'll just poke that in, I'll tilt it across like that. So yeah, it starts high and it settles down to about 3 or so milliamps. Okay, which is a good load to put in the circuit. It means you're not going to get like rogue readings from just leakage. These are the ones I've used. Well, you can see it's so scuffed. I've used them at work quite a lot. They used to have a continuity test that beeped, but I had two Duracell AAA cells inside it, and one of them decided to just completely leak all over the interior and wreck the contacts. So that's annoying. I've got another one now, but it's the newer model, and it's actually bigger and chunkier and bulkier. They seem to have added features that aren't really needed. It's just slightly annoying, actually. I kind of prefer that one. So getting back to this, I'm sure I did a little. Sure, got a little picture of this. Yes, this will make it easier to see. So this is the PTC thermistor. Plus, it's got this resistor in series with the LEDs. It's the same arrangement as my old Steinel tester, whereby the LEDs are just an inverse parallel going straight to the probe. But then they go through this resistor, and then they've got this little modern PTC thermistor here going to the other probe. And the value of this resistor is, it's red, black, orange, so that's 2, 0, and then orange means 3, so 3 zeros, so that's 20,000 ohms. And let's doodle that down. So that's the old one, old style, new style, which is generic Chinese clone. And we've got probe going through a PTC thermistor, PTC, which I've already measured and has a value of 3,000 ohms, which is quite high. Then it's going through this other resistor, which is 20,000 ohms. And then the LEDs. And then the probe. Very simple. It's not. It will actually give you a rough indication of the voltage just in the intensity it goes in the behaviour, but it's designed as a cheap, simple, pocket tester. I mean, they're not expensive. They're about less than £5. Is it £3.50 or something like that shipped? The thing is, sticking this across 415 volts, it says 380 volts, and I'm guessing it's just based on. I take it if it's based on the Steinel, then their voltage would probably have been 220 volts, in which case the voltage between two phases would have been 380. So maybe they've just, oh, you know what? It's because it's Chinese, isn't it? And their voltage is still 220. But the 6, starting at 6, that does allude to the fact it's based on, well, the circuitry as well, and the shape suggests it's based on the Steinel. So I'm not sure if I'd trust this in 415 volts. I think I'd rather, if I was doing industrial stuff, I'd still rather use the trusty fluke that's going to, if it blows up, you can say at least I was making an effort to be safe. But for 240 volt use, I would say these are going to be okay. Now, based on that resistor there, I couldn't work out initially why they've got that, unless it's just to allow them to use a standard PTC thermistor value. But I'm thinking it's actually maybe so that it doesn't trip the RCD if you go live to earth, because in the UK we have the 30 milliamp trip RCDs, and let's stick this in. I should actually stick this clamp meter in this as well. We'll do that after. But if I go from here to earth, it's showing the 240 volts to earth. It's lighting visibly, nice clear indication. But if I tried the same with the flukes, and I'm not going to do it right now because the RCD is out a wet walk to a garage, but it says in the instructions for these that, you know, if you test straight between live and earth, it'll trip the RCD and they make it out that it's a feature. But if you actually go live to neutral first, see if I can get the probes in here, until that current drops down and then you go live to earth, then it doesn't trip it. It actually, it holds because the current, you know, the resistance is shot up in this. Is that staining or have I managed to bruise myself? Probably done something to myself. Oh, not to worry. That happens a lot. So let's actually measure the current through these. I wonder if technically speaking, if we've got basically 20,000 ohms plus 23,000, best part of, you know, that's near enough to 3240. Is that going to be 10 milliamps? So let's stick this little meter in, we'll stick it in like this and we'll just see what it actually shows. Yep, near enough, 11 milliamps. Is that going to be enough to warm up the PTC thermistor, or is that just purely for the higher voltages? What would the dissipation be at that? That would be 0.01 times 240. That's dropping. The dissipation would be about 2.4 watts. I reckon that's rated about 1 watt, that resistor. But the PTC thermistor is now kicked in. The LEDs have gone much dimmer. They're still lit. But it's now cut down. It must just be a safety feature. And also to kick in if it's used in the higher voltages. These things aren't designed, you can't just leave them in a terminal all the time. They're just designed for probing about for brief use. But that obviously the PTC then is being used for that limiting factor for the higher current that would flow when you used it in a higher voltage. But the downside of that is because they've got this high value resistor, this also limits the current to a level that won't trip RCDs. But because of that high value resistor, if you use this across 6 volts, I mean this one says 6 volts, the other one says 10 volts. When you're using them at those low levels, it really is. It's, you know, if you're using it in your car or something like that, you'd have to really shield it to see if it was glowing or not. And that's maybe, I think maybe they've just used, they could have used brighter LEDs. They've used the fairly dull 660 nanometer ones, and also, unlike the original Steinel where they were sticking through the front of the case, they've just got them sort of glowing against this label, a label which this is clearly the same case is used for all the different testers in the range. I do have another one on order, which I thought I'd ordered one already, but unfortunately it was supposed to be 3-in-1, but they showed a picture of the 3-in-1, but the listing was for a 2-in-1, so I ended up with another one of these. But the other one has 3 neons and presumably a resistor divider. I'll do a video of that when it arrives and we can take a look at it. But the other one's in the full luxury model, you know, it's one of these things that they ration out the features. The base model's about £3.50 and then the price climbs up depending on what features you get. The other ones have the 6, 12, 24, 48 and then it's like 110, 240, 415 sort of thing like that, implemented with neons. But yeah, on the lower voltage ranges, these are pretty useless to be honest, because I would say let's turn the power supply on. Let's stick it to about 12 volts, and you'll see what I mean. So let's stick this up to say 12 volts, and if I stick it across this one, for instance, yeah, it's you can't even see that, can you? I can see that the positive LED is glowing, but it's so dim. No, you're not catching that at all. What if I do it in the one where it's actually open? Any better? Oh, you can barely see what I mean. That's just miserable. That's, you know, I don't know what's that current's flowing there. I'd have to use. Oh, let's hold on. I can tell you what's current's flowing. Let's use a wee dinky meter here. Let's stick it unambitiously to 2 milliamps. Yeah, it's not a lot, is it? It's about half a milliamp, but you know, half a milliamp's still a modest amount of current. That should have made an LED glow at modest intensity, but that suggests that they've just over cheaped out. They've used the cheapest LEDs they could get, so that's a bit crap, isn't it? But then what do you expect at that? However, at 240 volts, I would say, you know, they're nice and bright, and the circuitry seems reasonable enough. It's still infinitely superior to things like this. It will give you that proper visual indication before you start poking your fingers and things. You know, if you've got, you can test live to neutral, live to earth, and see if you've got a live connection there. But yeah, these are interesting. It's quite neat to see that it is basically a clone of the Steinel. But other than that, you know, they seem quite functional. I did order quite a few and I compared them all. The circuit boards, incidentally, are all identical. But yeah, it does seem to be a clone of the Steinel, and it for, you know, up to 240, I'd say. I'm not sure I'd trust them in 415 or even like the 400 or the 380 or whatever, but for anything up to about 240, I'd say these actually look quite acceptable for use as test lamps. Not so great at the DC though, but you know, it's you know, for mains testing, I'd say they're fine.